In the previous video, we started filling out section number 4 of the Unit 8 flipbook. We covered the properties of a 45-45-90 triangle and how we can use a shortcut to figure out the side lengths of that triangle if we're given one side length. We can find the other two with very quick calculations without having to use Pythagorean theorem. Well, the 30-60-90 triangle has the same type of properties. They'll look different than this, but they also give us a way to quickly find the missing sides of the triangle. So let's talk about first why 30-60-90 triangle. Why is that such a common triangle to use out in the field? And again, I use that very much when I was laying out measurements in backyards. So where does this 30-60-90 triangle come from? Well, it comes from an equilateral triangle. So in this case, let's go ahead and draw, and I'll just write here so that we can verify. We are going to draw an equilateral triangle. Boy, that's pretty messy. I hope you guys can read that. An equilateral triangle. We know that an equilateral triangle has all sides congruent. Let's label those. Let's just say, for example, that that side was 8. If this were an equilateral triangle, all sides would be 8. And we also know, since the interior angles of a triangle always add up to 180 degrees, then we also can say that the angles of an equilateral triangle will always be 60 degrees. That's because all sides are congruent, so all angles must be congruent. And 180 divided by 3 is 60. So there we have an equilateral triangle. Well, here is where a 30-60-90 triangle comes from. Take out your ruler, and I want to have you go ahead and draw a line segment from the top of that triangle straight down to the bottom. Move that over a little bit so it's lined up right. This is called an altitude of a triangle. And we're going to note here that when we did that, we created a 90-degree angle right here. Altitude is an angle that is perpendicular to a side of the triangle, and it goes directly to the opposite vertex. When we did this class, we actually created a 30-60-90 triangle. This angle right here is 90 degrees. This angle is 60 degrees, just like it was in the equilateral triangle, and this angle is half of 60 because we are bisecting this angle. So that is, kind of hard to write that in there, that is 30 degrees. So here's where we get a 30-60-90 triangle. Now, there's a couple things we know about the sides. We know that since we drew this line straight down from the top through the middle, because we bisected this angle, we also bisected this particular side because it is an equilateral triangle, and that means we know that the length of this side is 4. Let's go ahead and label our vertices, by the way. That's A, let's make that B, and let's make that C. Okay, we know that the hypotenuse didn't change. The hypotenuse of this right triangle is right from the equilateral triangle. We know that's 8. So the only question is, what is the length of AC, our third side of our right triangle? Well, to find AC, we can use Pythagorean theorem. You can see in our previous example, we found AB by using Pythagorean theorem. Here we're going to find AC. So in this case, we know one leg, that's 4, we'll square that. We know the hypotenuse, that's 8, we'll square that. We don't know the missing side here, so we're going to put an X there. That's our missing leg. Alright, let's go ahead and square 4. That's 16 plus X squared is equal to 64. We're going to subtract 16 from both sides, and we're going to get X squared equals 48. And now we know we're going to square root both sides, and we end up with X equals the square root of 48. Now I'm not going to put this in my calculator because I want to simplify this just like we did in the previous example for our 45-45-90. In the rules of simplification, we can factor this number and try to find a number factor that is a perfect square, and we can find that because 48 is just the two numbers, square root of 16 and the square root of 3. Take a look at this. 16 times 3 is 48. So square root of 48 is the same as writing the square root of 16 times the square root of 3. And we know the square root of 16 is a perfect square. And we end up with 4 times the square root of 3. And that means the length of AC is 4 times the square root of 3. And this leads us to a very interesting property. Let me correct that here. I want to make sure you guys read that, okay? This is 4 times the square root of 3. And here is our property of all 30, 60, 90 triangles. When you look at this triangle class, I'm going to go ahead and label this as 60 degrees. We know the other angle has to be 30 degrees now because these angles add up to 180. 90 plus 60 is 150. 180 divided by 180 minus 150 is 30 degrees. And here is our property. If you look at these two legs of a 30, 60, 90 triangle, they're not congruent like a 45, 45, 90. One of them will always be shorter than the other. And that short leg, let's just say that the measure of that short leg is equal to x. Well, that means, take a look at our example up top. That means the hypotenuse is going to be 2 times that. So the hypotenuse is going to be 2 times x. See how we had a 4 here? That was half of the side of the equilateral triangle, and the hypotenuse was, of course, double that. And now the long leg, the longer leg of the two, that one is going to be x times the square root of 3. Take a look at our example. If x was the short leg, then x times the square root of 3 is the long leg. And these rules can be used to find missing sides of 30, 60, 90 triangles. So let's write this out. If this side, the short leg, is x, then the hypotenuse is 2x, and the long leg is x times the square root of 3. And these rules apply to 30, 60, 90 triangles. 30, 60, 90 triangles. All right, let's do some solutions based on this. Here's our first question. Find the missing side measures. This is a right triangle. It's a 30, 60, 90 triangle. They gave us the hypotenuse. Let's remember our rules. Short leg, I'll just abbreviate that SL. That's x. Hypotenuse is 2x. And the long leg is x times the square root of 3. Okay, well, they gave us the hypotenuse. So we know the hypotenuse is going to be 2x, the short leg is going to be x, and the long leg is going to be x times the square root of 3. So that means 2x equals 12, because 2x is the hypotenuse. If we divide both sides by 2, we find that x equals 6. Since our short leg is just equal to x, then our short leg must also be 6. Let's write our measurement here. This must be 6, and our unit of measure is centimeters. So our short leg is just 6 centimeters. Now our long leg, I'll put this in a different color so you can see it. Our long leg is equal to x times the square root of 3. Well, we know what x is now. X is 6. So the long leg is 6 times the square root of 3. Let's put that in our calculator. Oh, I've got a different thing up. Hang on one sec. Here we go. Here's our calculator. Let's move this over. So let's plug in 6 times the square root of 3. Close the parentheses, and we have 10.39. We can round that to 10.4. and the long leg is equal to approximately 10.4 centimeters. We could have written up here, if you wanted to, you could have written this as 6 centimeters as well. So we just found that our long leg is equal to about 10.4 centimeters. Okay, that finishes that triangle. Let's do one more. Here's another 30, 60, 90 triangle. This time they gave us the long leg. Before you start solving this, write down your rules for 30, 60, 90 triangle. Short leg is going to be x. Hypotenuse is going to be 2 times x. The long leg is going to be x times the square root of 3. Okay, so they gave us the long leg. We know the long leg is x times the square root of 3. Let me write that in here. This is going to be x times the square root of 3. This is going to be 2x. This is going to be x. That means we know that x times the square root of 3 equals 18, because that's the side they told us. Let's divide both sides by the square root of 3. We end up with x equals 18 divided by the square root of 3. Let's put that in our calculator. Find that. Okay, we've got 18 divided by the square root of 3. Close our parentheses, and we have approximately 10.39, so about 10.4. So x is about 10.4. And let's go ahead and use that now. Well, the short leg is equal to x. So the short leg is equal to x, and that is, of course, 10.4. In this case, we've got meters. So we just found the measure of x, 10.4 meters. Okay, last thing we have to find is the hypotenuse. Well, we know the hypotenuse is equal to 2x, and we know what x is. X is about 10.4, so the hypotenuse is 2 times 10.4, and that's going to be 20.8, and our unit of measure is meters, so we just found our hypotenuse, 20.8 meters. And that's how we use the rules, special triangle rules of 30, 60, 90 triangles to find the measure of the missing sides without having to use Pythagorean theorem. Class, if you plugged 10.4 and 18 and 20.8 into the Pythagorean theorem, you'd find there'd be a slight rounding error, but you would find if you did 10.4 squared plus 18 squared, you would get, for the value of c, somewhere around 20.8 with a minimal amount of rounding. So I hope you use these strategies for solving special triangles. If you do it this way, it's very clean, very organized, and it doesn't take a lot of thought to figure out how to find your missing sides.